Hey, we're back! Episode 3, Season 2! Yeah! Okay, so behind me is a green screen. I am using Linus's help, because he is awesome, so that I can show what we're doing with the table at this point. Remember the basic table? That's going to be just a start, and we're making it into a train yard, so that we have plenty of storage. Now, we're going to take the green screen, and we're going to turn it into our layout. Here on the layout, this side, the original, see all the straight lines? That's what we were going for. But then I talked to my friends and they said, that's no good. You don't have enough storage. I said, well, maybe you're right. So we changed it, and now we have this. This gives us a chance to pull the trains all the way through, really nice and fun, and we can make full loops out of it. I like this a lot more, and the guys are really super stoked about it. The longer trains that need long sweeping arcs, they get the outside. Short trains that are for fun, they get the inside. What we're concentrating on today is the slope. See this little circle right here? This is how we're going to get from the bottom layer up to the top layer. It's going to look like a slinky going up. And we're going to talk about how we figure out how we're going to do this slope and make it work right. Can't wait to have fun with this! Let's go to the whiteboard. It's time for us to figure out how we're going to get from the lower level to the top level. Some of the reasons I'm doing this, I need to know how big my circle is going to be. So bear with me a moment. We're going to be going over a little bit of math. A good layout uses math. The better things are calculated out, the smoother they run. It's not just thrown on there, and it can be deceptive that way, but you are actually building a railroad. You're building a real railroad, you're just building it much smaller. You're making a model of it, a functional model. I have Kato double track. Go over this in a moment. Kato 20-185 is the number of the pack. There's 2 pieces of track in each pack, 45 degrees each. So if we want a full loop of track, 45 degrees per piece times 2 per pack, $90 degrees per pack. There are 360 degrees in a circle. I know it's kind of a weird oddball number. Why 360? Why not 100? Why not 1,000? We do 360 degrees. So we're going to go 360 degrees divided by 90. It's going to take 4 packs to make one complete loop. That's how we figure that out. I said before, these are instructional videos. They're designed for children and adults. And it's literally the step-by-step on what you do to figure this stuff out. On the Kato, it is double track. 2 tracks. The idea is 1 track's for going up, 1 track's for going down. So I can theoretically do a loop. The outside track measures 18 7/8 inches in radius. The inside track measures 17 5/8 inch radius. Got to put my R in there. What I'm talking about when I'm talking about radiuses, Inside track, outside track. My center point. That's supposed to be an R. That's my radius. Comes in very important for calculating this. I want to go off of the inside track radius. So you're going to give me just a minute and I'm going to redo everything. Wow. Erased. Now, the 17 5/8 fraction. We're going to make it a little simpler. 1 7 5/8 inch radius equals 17.625 inch radius. That makes it a little easier to work with. We'd already established that it takes 8 sections, that's a lot of fingers, 8 sections to make one full loop. So 7.625 times 8 equals big time math skills. Hang on. 110.74 inches. That's my circumference. Okay. Our circumference, 110 inches, 0.74. This is the main number I'm worried about. Mostly, when it comes to trains, it is a 2% grade or less is what you're looking for. You start getting more than that, it becomes hard for the train to pull. Percent grade. That sounds kind of weird, huh? Let me explain. Imagine this is your train track and it's nice and flat. The metal rails, the metal wheels are designed for low friction, make it real easy to go down. No problem. And when it's flat, beautiful. So you have to go over something, or in our case, up something. 0% is flat, 1%, 2%, 3%, 4%. Now here we are at a 4% grade. This is exaggerated. And you want to walk up it carrying a bunch of stuff. It's a lot harder because you're not just going that way, you're going that way. And you're having to climb up it. Since the wheels are designed not to have a lot of friction to start with, to make it easier to pull, the larger the grading, the more they slip. So if it's too steep, even though it has all the power in the world, it can't get enough grip to go up. A lot of models actually have what's called a traction tire that makes it a little stickier, kind of like a car tire. And that's kind of a cheat. In the real world, they don't have this. In the real world, they don't want to have anything more than like a 1% grade if they can avoid it. In models, usually a 2% grade, works out really well for most trains. And it makes a practical rise over run. Rise over run. Our percentage, 2%. Make it real simple. $100, in this case, inches, that way. I want to go up 2 inches. For every 100 inches I go that way, I want to go up 2 inches. That is a 2% grade. Real easy to figure out. If I want a 3% grade, for every 100 inches I go that way, I want to go up 3 inches. Okay? Of a right angle triangle, this would be called the hypotenuse. For those of you in school, you're taking your math classes, hypotenuse of the triangle. This is where math saves everything. Yay! That's why I'm my old smart hat here. This hypotenuse is actually this number, because we're not going flat, we're going up a little bit. And this is going to be a little bit longer than this. Not a lot longer, but a little bit. All right, this part is just for anybody who wants to figure it out. Same triangle. 110.74 inches. That number here. Say 2 inches. That little square means 90 degrees. What is this length? Anybody who wants to calculate this out and leave the answer in the comments, just kind of a fun thing, interactive thing. I reinstated the comments so that I could actually talk with and communicate with the people that actually watch the videos.